Hello, everybody. Welcome. Welcome to day 2 of our Gizathon with another interesting workshop ready and waiting for all of you. Today's topic is going to be full stack Giza, and we're going to be having 2 of the Giza team members on this workshop to present and walk you through all the important bits. Let me just quickly get them on stage while we go through some other details. We have Raphael, and we also have Ege from the Giza team. Just quickly add them on stage. In the meantime, do make sure to say hi in chat. GM everyone, let us please be active. Make sure to post all of your questions in chat. There's a lot of people from the Giza team that will be helping you out today and answering any of your questions.
Hey guys.
Yeah, so a few things to go over. Everyone, please, if you have any questions or so far, if you've not yet found yourself a team, please navigate to your hacker packs, which have been sent to you, and we constantly keep on reminding you about. You'll also find links for them in the notifications and announcement channel on Discord, as well as they've been emailed to you via the onboarding emails, and you will be able to find multiple ways to find yourself a team if you don't have one. You're perfectly fine to work and create something on your own, but it's always more interesting to work together and knowing you can rely on somebody else. So yeah, happy to have you all here, and I would like to give the word to Raphael to kick things off. How are you guys?
Thank you guys. Thank you, Encode, to hosting us, and really exciting about that hackathon and what you guys will build with Giza, with the Giza stack, with the AI agent narrative. Yeah, so I'm really excited about it. Let me share my screen quickly. I'm gonna introduce quickly about what we do at Giza. Even if yesterday you already have a full presentation of what is Giza. And then Ege will talk about Giza Datasets, and then I'm gonna do the workshop for the verifiable machine learning. Okay, first of all, I'm gonna share with you that link. This is the link of the documentation at Giza, and you will see all the information of what we are doing at Giza. At Giza, we have 3 main products. We have the platform, the AI agents, and the dataset. The platform is the platform, the product, in order to make zero knowledge machine learnings, to verify your machine learning models. What it means take a model, transpile a model to ZK circuits, deploy an inference endpoint where when you call that inference endpoint, it will run for sure the model, but also prove the model. Download the proof, verify the proof. We'll talk about all of this today during that workshop. Then we have the AI agents. The AI agents is the bridge between zero knowledge machine learning and on-chain smart contracts. ZKML is doing the computation off-chain, proving it, and then you can do some actions on-chain. And the AI agent is that bridge that link the off-chain ZKML world to your smart contract and make your smart contract smarter. And then we have the data set that Ege will talk about in a minute. That is a curated library. A library with a curated data set, a bunch of curated data sets for the Web3. Okay, but I'm gonna let Ege first to talk about data set, and then we will have a full workshop about the platform. And tomorrow you have a full session about AI agents and how you can use what we saw today with the platform, with the inference, to use it with the AI agent and use it in your smart contract. I'm gonna let you, Ege, to talk about dataset, and then I'm gonna talk about the platform.
Thank you so much, Raphael, for the introduction. So, hey everyone, I wasn't able to come to the workshop yesterday, so I'm really happy to meet you. My name is Ege. I'm a core data scientist in Giza. And today I'd like to quickly essentially introduce to you how Giza datasets work and why is it there. And as a data scientist, obviously, one of the essential elements of any model development process is obviously always the data, right? Collecting the right data and making sure that it's in the right format, etc. It usually takes more than half of your time when you're developing a model. And specifically for Web3 data, one of the challenges that we have seen quite early is if you are even for Web3 developers, it's relatively difficult to collect data. But if you're inexperienced with Web3, data collection is actually one of the hardest things you can understand, because you have to know how blockchains work, you have to know how smart contracts works, RPC nodes, etc. These are all complexities that really make it difficult for a non-native, non-Web3 ML developer to build his or her first model. So for us, essentially Giza Datasets is like a low-hanging fruit in the sense that it's not difficult to make, but it's actually, we have seen a lot of impressions, really good impressions for it. People saying that it's really useful, it's really changed their model development, etc., to be much easier. So I think it's a really valuable tool in our toolset. So what I'm essentially talking about is what Raph just showed us is the datasets, which I believe is the first stop in our sort of tech stack, right? You want to build a model and you want probably like a Web3 related task. You have a Web3 related task to solve. How do you collect the data, right? This can be a DeFi model. Perhaps you want to do something with, concentrated liquidity pools in Uniswaps, perhaps some lending or trading agent, etc. You obviously need data. And what Giza Datasets provide is tabular data, right? Data that is already curated for you to then build on. And also historical data of, historical market prices, historical, if you're interested in let's say decentralized social protocols, you have the historical messages, all the tweets or all the messages in Lens protocol, etc. You have a lot of different options there. But the idea is to make sure that any sort of incoming ML developer in the space can build his or her first model as fast as possible. And how we achieve that is we essentially have this data SDK, which can be run directly on Python. So you don't need to, all the RPC nodes, all the sort of intricacies of Web3 data is completely abstracted from you. You essentially download this SDK, which is combined of two different classes. One is Datasets Hub, and the other one is Datasets Loader. What Datasets Hub allows you to do is essentially search through our library of datasets to make sure that you find the data set that you're interested in, right? So just to quickly go over how the code works is you first import the Datasets Hub class, and after it, you instantiate it. And from that, you can essentially, if you already know the name of the dataset that you want, you can easily go and get it, which essentially shows you all the details of that dataset. If you want to go, let's say, I'm interested in liquidity, you can also use Hub to get all the datasets that are related to liquidity by the get by tag function, and things like that. So Datasets Hub, in essence, allows you to search through and query our datasets library. What Datasets Loader does is essentially, so all the data that we have is hosted in our GCS pool, And what the datasets loader does is essentially, if you have the name, if you know which dataset you want to get, you use datasets loader to load it. Inherently, like we use polars rather than pandas, but if you are like we use polars because it's much more efficient in especially some cases. But you can, like, if you're more sort of acclaimed for like pandas, you can also easily convert that polars data frame to pandas when you load it, right? So you instantiate the loader, and then this is a little bit of detail, but sometimes we have this like certificate error, so you have to type in these lines as well. But you then just like one line loader.load and the name of the dataset that you want to load, and voila, you have it. Curated dataset directly in your Python environment. We also have some eager mode and cache management that allows you to do, certain more advanced data, data loading functions if you're interested in that. But in essence, it's a relatively easy SDK, and it's direct to the point. In our documentation, we also have the hub, which allows you to search through the different datasets we have directly in the documentation. So we have the aggregated datasets, which essentially are like more high-level token data, market data, etc. That's that is like somewhat protocol or even network agnostic. But you also have protocol-specific data, right? For Aave, for example, daily deposits and barrows. If you want to build something on Aave, we have balancer curve, pancake swap, etc. So most of the high TVL DeFi protocols we have. In addition to that, we have some socials that we have recently added. And this is a weekly effort. So every week we are essentially adding new data sets. And yeah, we are really, really interested in this. We have seen a lot of interest in other people, especially for building their first two couple models. Because after some point, obviously, as you get more advanced, you know how to get your data. But I think Giza Datasets is a wonderful tool to help you kickstart your Web3 data science career. Thank you, Rafa. Perhaps we can go back to you.
Okay, so Vivek, you saw what is the benefit of the dataset SDK. Now let's talk about platform. But before to talk about platform and ZKML, let's just understand why we need to make ZKML for AI agent, because this is the goal of this hackathon is to build agents. What is an agent first, and why we need ZKML for that? Let's say that you want to create a prediction model, that an agent that will predict the price, and based on the prediction, you do an action on a smart contract. You buy or you sell. What we want is that the agent first does that prediction, okay, and then based on the prediction, the agent will do the action, but we need that this prediction needs to be verifiable, okay, needs to be proved. And if the inference was proved, we are in a trustless environment, so we can do the action on chain. So this is why we need ZKML for that, okay? So what we will see now is how to make from end to end the verifiable inference, okay? And tomorrow, again, you have a full session of agents. Okay, so let me share first with you the link of the notebook of the repo of the workshop. You have also the tutorial here in the documentation at the tutorials section, okay? But now I'm gonna do it as a notebook. Okay, first thing that you have to do before anything before using Giza tools, you need first to install the Giza CLI. With the Giza CLI, you will be able to do some stuff that we'll see in a minute, and then you need to install the agent SDK. This is in the documentation. Okay, if you go to the installation area, you will see all the instructions to install the CLI, the agents, and also the dataset SDK that Ege just talked about. Then once you install everything, you need to create a user account, okay, on our platform. Or if you already created an account, you need to log in. And it's optional, but highly recommended to create an API key for your development UX. It will be better because instead of reconnect every 2 hours, you will be able to have your API key in your environment. Okay, so the idea of that workshop is to train a simple XGBoost model on the diabetes data set, and then we will see how to transpile that model to ZK circuit, and finally how to deploy an inference and run a verifiable inference. So as you can see here, I just loaded the simple diabetes data set and created an XGBoost model. Okay, so I do it like that. Then I'm gonna save the model, and then our platform is supporting 3 kinds of models currently, of frameworks currently, to transpile to ZK circuits. We are supporting XGBoost. This is what we are using right now. We are supporting LightGBM, okay, and we are supporting ONNX models, okay. ONNX, for people that are not familiar with it, is a framework for deep learning, more deep learning focus. The idea is to have an interoperability between different machine learning models, machine learning frameworks. So, for example, if you have a model that you made in PyTorch or TensorFlow, you can easily convert it to ONNX, and then based on your ONNX graph, you can transpile it with our platform. I'm going to show you that in the minute with that command. Just be aware that ONNX it's a huge framework, okay, and and with a lot of operators. When we talk about operators, we talk about functions that will constitute the graph. For example, a softmax, a linear operator, etc. And because you can create huge graph, all operators are not supported yet at Giza. You have all the full list of supported operators in the documentation, and also when you create a big graph, so a big model, currently the program that we transpile, so the ZK circuit that is coming from that graph can be too big, okay, to prove. So yeah, be aware that when you are using ONNX, don't create very complex graph. You have a section in the documentation about limitations, okay, to understand better the limitations. But we highly recommend to use the XGBoost if you can for your project. Okay, this is the model that is working pretty well, and it will avoid errors. And for many use cases with agent, XGBoost is enough, in my opinion. Okay, so now that we said that, we train the XGBoost model, we save the model, and then once we save the model, let's transpile it on our platform. So what we will do here, we'll run that command, okay? And this will do a bunch of operations in our Giza platform. The first thing that it will do, it will create an instance of your model, a model ID, and an instance of your version. Okay, you see here that my model ID is 588, and the version of my model is 4. Why? Because I run that workshop a few times, so that's why I just created the fourth version of that model. This is a good way to have some kind of versioning for when you create a model, if you want like to update it. Once once we created the version and the model on our platform, then we are starting the transpilation. So what the transpilation means, we take your model, okay, that you may train with Python, and then we convert it to ZK circuit, and to convert it to ZK program, what we do, we are using Cairo. Okay, so we created a library called Orion, where we represented many functions in Cairo. And what we do, we just do the mirroring between XGBoost and the Cairo version of XGBoost. Okay, so this is what we do here, and at the end we have a Cairo project called the Scarb project. Scarb is the package manager of Cairo, with all the transpilation. I can quickly show you if you want how it looks like. Here, if you go, once we did the transpilation, here you have the transpiled project. Okay, so the Scarb project, and here you can see the Cairo file from the transpilation. This is the implementation of XGBoost, and this is the transpilation with your actual data. Okay. Also, what we did on our platform, we also compiled your Cairo project, and we compiled it as Sierra. Sierra is compiled an intermediary representation of Cairo. And now we are ready to deploy verifiable inference. Okay. Once we have this Sierra, we will be able to run the Cairo VM. Okay. And this is what we will do. So first, what we need to do is to deploy an inference endpoint. So I'm gonna just update the version ID, because this is version ID 4. It's the same model ID, so I don't need to update it. And what we do here, by running that command, is that we deploy on our platform an inference endpoint. So we will have a link, okay, a URL, where when we do some curl requests, so this is the URL, okay, I'm talking about, and when you call some curl request at that URL, it will run the model, the Cairo program that we just transpiled and saved, but also it will in parallel start a proving job that will run your program, and sorry, that will prove your program. So first we run the program, but we also in parallel start a proving job that will prove the execution of your program. Okay, but the thing is that it's nice you have these URL, but for better UX, maybe you want to create a workflow and to use it directly in your Python code. So we created an SDK for that. And with the SDK, I'm gonna again update the ID. But with the SDK, you have the Giza model, which is a class where you can specify the model ID and the version ID that you are using. And the Giza model will check on our data set, the model that corresponds to the Sierra program, the compilation, the Cairo compiled that corresponds to the model, your model ID and version ID, and run, and then you will be able to call the predict function from the model. Okay, and that predict function, with that predict function, you will be able to predict an inference. Okay, to call the inference. If you put the verifiable mode to false, it will run an inference without like the Python code, okay, without Cairo. If you put the verifiable mode to true, it will run the Cairo VM. So it will run the Cairo VM. It will call that endpoint URL. So it will call start the Cairo VM and start the proving job. Okay. So this is what we can do here. But also for some development experience, it's better sometimes to don't start the proving job each time that you want to run a prediction. So why? Because you are limited in terms of how many proving jobs you can start per day. You have all the information of how many proving times you can start proving jobs. Sorry, you can start per day here in non-limitations. Okay, of the documentation. You have everything here. So sometimes you don't want to run an inference with a proving job. So if you don't want, but you still want to run the Cairo program just to see if all the transpilation and the inference worked pretty well, you can pass the dry run parameter. Okay, and by doing that, it will execute. It will call that endpoint, execute the inference, but we will not start a proving job. If you put that false, it will start the proving job. When you do the inference, as I said, it returns the result. The result of the prediction and a request ID. That request ID can be used to download your proof. Okay. So right now, because I'm talking, and right now we started in parallel the proving job, but I'm gonna use a previous request ID because we don't have a lot of time to wait. So this proof was already was ready, but you can get the status of your proof by calling that command. Okay, so by calling that command, you can see if your proof is ready, okay, or if your proof is not ready. So let me show you, for example, if I take that one, it will tell you that this one is not, that the proof was not found. Why? Because the proving job is not, it didn't start it, or the proof was not ready. Once your proof is ready, you can download it. Okay, so by calling that command, Giza endpoints download proof, with the endpoint ID and the proof ID, you can download the proof, okay? So the proof was downloaded, you have it here, okay? And then we have two choice. You can use we are using the Platinum Prover from Lambda class. So you can use the Platinum Prover to verify the proof that you just downloaded, or if you want, if you don't want to install any provers and just quickly verify on your own, you can verify it with our verifier API. So to run the verifier API, you give the verify proof ID and the ID that you get from the status, okay? And then when you do it, it will verify the time, okay? So that's it for the full verifiable inference stack. Let me know if you have any questions. If not, we can talk about a few things that I want to mention also.
I think we have one question from George.
I think that was answered in chat a bit from Fran, but there's a new one from Satya as well. And also, I suggest for everyone that is going to be watching the recording to also read out the questions before giving an answer, so that people watching will be knowing what the conversation is about.
Yeah. So yeah, Fran just answered that question. I'm gonna jump to the other question. Sorry. Yeah. So about what the proof is, it's true. What Cairo does, it will prove the integrity of a computation. Okay. So what it means when we are using Cairo for machine learning, we prove to a party that we executed a program without we executed a program correctly without for the party to rerun the program by himself. So for example, when you are using ZKML for an agent, okay, for an agent narrative, you prove to a smart contract that you did the prediction correctly, okay, or you didn't use another model, okay, or you didn't bias the result. So your smart contract can trust you in order to make an action on chain. So this is what we means when we prove when we prove the inference. The proof is never done on chain. The proof is done off chain, okay, and then it can be verified. Right now, it's verified off chain. In the future, in the near future, we will have the verifier on chain. But for the moment, the verifier is off chain. In the near future, it will be the verifier will be on chain. However, the prover will always be off chain. The prover is intensive in terms of computation, so it will always be off chain. Yeah, exactly, Satya. In the proof in the ZK proof, you have the hash of the program hash, so you can so the verifier is agree about the model here. It's a good question for the prediction. For the quantization, sorry. Currently in Orion, we are using FP 16x16. You have documentation of it in the Orion documentation. I can share it with you if you are interested on. We created a fixed point implementation. We have different design for fixed point implementation, 8x23 and 16x16, and other precisions. But for the moment, in the transpiler, we are only using these 16x16. In the future, we will support more modular data types. I'm gonna share with you that documentation if you are interested. How to integrate an agent in smart contract. We have a full session about it tomorrow, so I'm gonna not dive into it. But you have in the documentation that I shared with you, you have you have the full AI agent documentation. You have also tutorials to do it, and tomorrow there is like a full session of AI agents. But basically, we created an AI agents SDK in order for you to create easily, to integrate easily your verifiable inference that I just shared with you. You know, these endpoints that we just deployed, okay, in a smart contract. In an agent that will be used by a smart contract.
We have a couple of questions in the questions tab if you want to reply to those from Ramiro and Sergey.
Okay, about Yama, it's like I missed some question first from Ramiro. Do the input arguments for the verifiable inference remain private in this case? For the moment, we don't handle private inputs. This is another topic that we plan to tackle around August. Okay, we have some ideas for that. We want first to support Noir, because currently we are supporting only Cairo, but we want to support Noir language for that, and we want also to support Cairo hints. If you are familiar with Cairo, you know about what I'm talking about. And with Cairo hints, we can do some kind of privacy. But right now, this is we don't tackle that use case for the moment. Can we combine proof with Yama model in any case? No, not for the moment. As I said at the beginning of my presentation, we highly recommend to use the XGBoost, okay, because this is the one that is working pretty well. You can create neural network with, or a graph with ONNX. Here you have all the supported operators that we support right now, but you have to have in mind that big models will potentially fail due to the model complexity. And also for Yama and transformers, there are a bunch of operators that we don't support yet. In the future, we will have some proof parallelization we are working on right now that should come really soon, that where you will be able to support more fancy models, I would say. But for the moment, we highly recommend to use like small model like XGBoost. And in a minute, I'm gonna talk about a few tools that you can use in order to check your limitations and also to find some workarounds for that. Can we? Yeah. Then hello. This friend just answered for the George question. Let me just jump on the chat. Okay, I think I answered all questions. Will we be covering on-chain verification? No, tomorrow you will. Tomorrow it will be a session focused on agent. So as I said, agent will use the verifiable ZKML, verifiable inference, and based on that prediction, we'll do an action on-chain. The on-chain verifier will be added in in 2 months, I think. we need first, because the thing is that we are using a prover right now called Platinum, and this prover doesn't have a verifier on chain. So we need for that to switch to another prover, and we are working on that right now. Let me share now with you how we can reduce the complexity of your model. Our data engineer lead at Giza created a great tool called MCR, Model Complexity Reducer, where you have a full tutorial here, where you can take a model, this is like GBM model, and reduce, put that in the MCR algorithm that he created, and will return a new model that was reduced and found a workaround between the reducer and the performance. So we highly recommend to use it. This MCR is working with is supporting with the XGBoost regressor, XGBoost classifier like GBM, and we are working on logistic regression. Hopefully we will support it for next week. We encourage you to use this MCR. You have also the full paper here. The link is in the documentation if you want to dive more into the algorithm and how we manage to do the model complexity reducer for that. Okay. So you have to have in mind that when you do ZKML, you are not running a regular program. Okay, like a Cairo program is adding a lot of overhead, and so you have to have in mind that we need to have a model that is small enough in order to be proved. In the future, we are working on some stuff, as I explained, for parallelization and supporting more operators. But you still need to have in mind that the model needs to be as small as possible in order to reduce the proving time. You have also the benchmark CLI. This is a CLI that we created that is running completely locally, in order just for you to have some benchmark on, okay, how to I created that model and how many times it takes to run, to prove, and to verify. For that, you will need to first install the Platinum prover, the prover that we are using internally at Giza, and then install, of course, the benchmark CLI. And then once you install both of them, and when you use it, it will run the entire Cairo stack. So it will start the runner with the Cairo VM, the prover, and the verifier, and give you some insights about the time and memory, and also Cairo steps. If you are familiar with Cairo, you know what I'm talking about. I'm gonna check if there are any questions. Yeah, exactly. Fanfare. The prover takes the model, the model and the inference, so the input of your program, and the model is represented as a Sierra file, and then we start the Cairo VM that generates some files that we need for the prover. Santia, I think yes, and maybe you can answer that question. But yeah, I think that session is recording, and you will be able to review that.
Yeah, as I mentioned, all of our workshops are recorded, and we are trying to add them as soon as possible. So the moment the workshops are done, we are doing a bit of post-processing on our end and editing, and then you should be expecting tomorrow morning, depending on what time's on your end. So in less than 24 hours after the event, all of the videos will be shared with everyone participating in the hackathon.
Yeah, I am waiting any other questions. I finished the workshop, so let me know if you have any other question, guys. I can give you like just a walkaround about the documentation. Here you have everything what you can do with Giza. The installation, we highly recommending to do the quick start first, a bunch of quick start. You will have a better idea of how Giza is working. Create login and user, transpile the model, and deploy an inference, what we just saw. Then create your first AI agent. You will deep dive more into it tomorrow. But if you want to see it, we highly recommend it to do the quick start first. And then you have also a quick start for the datasets SDK. Then you have the contributions guideline. Most of our technology is fully open source. We have the Giza CLI repo. You have the agent SDK, which is open source. We have Orion, this library that is writing in Cairo, and in the future in more language like Noir. So all of this is open source, and we also reward all of our contributors for Only Dust. So you can read it and see how if you want to contribute to the Giza stack. And then you have the full documentation of all our products. Then these are the third-party tools that we are building for the Giza ecosystem. And then you have tutorials. In tutorials, you have different tags. This is more MNIST neural network tutorial if you want to see how to do to see what we just saw, but with ONNX and neural network. And here you have like more traditional machine learning models. But all of them are like beginner tutorials. Then you have the AI agent with a beginner tutorial and some intermediate or advanced tutorials. So yeah, we highly recommend to start with the quick start and then see the tutorials and then maybe dive into the product documentation. Voila. Tomorrow you will have a full session of AI agent, how it's working, how you will use the verifiable inference that we just created in order to use it to link it to your smart contracts.
Right, for everyone, I just wanted to quickly add a few things. There's been a lot of links that have been shared, both in the chat as well as at the very beginning. For those of you that are thinking they're missing out on them, don't worry about it. Everything is already within the hacker pack. So I'm quickly going to share a link with all of you. It should show up as a pop-up on the bottom left side of your screens. This is the hacker pack. Please have it open in your time at all times. It's already been shared multiple times with you both via all kind of emails, and we keep on sharing via the announcement channels on Discord. All the important links, documentations, bounty descriptions, recordings, everything is eventually finds its way on that hacker pack. So feel free to use it to your advantage. There's links to the team creation boards, as well as the form for you to add your profile to that board as well. And you will also find information on the idea submission form, which, as I mentioned at the very beginning and also announced on Discord a bit earlier, this hackathon will have a dedicated idea submission form, which will have to be filled out before the end of the week. You don't have to do it right now. Feel free to adjust and follow the workshops as they're happening, so you can get an idea of what you would like to build. But before the end of the week, we will require you all to fill that out, so that the Giza team will be aware of what you want to build, so that they can themselves plan on the resources that they can allocate to help you achieve the goals that you've set for this program. That is mostly it. And the most important bits that I wanted to note for tomorrow, as I said, it's going to be a very busy day. We'll have a couple of workshops, one starting at 5 p.m. Central European time and another starting in 7. The one in 5 will be on mental models for ZKML and its applications. And then at 7 p.m. we'll be going through the fundamentals of on-chain agents. So please make sure to get prepared, have a look at the hacker pack and see the information that might be of use for you, and come on board again tomorrow for more interesting Giza workshops. That's all for me. I don't know, Raphael, Ege, if you want to share some final words.
Yeah, just from the question, I'm not sure that I understood fully the question, because it was in multiple parts, but feel free to ask it on the Discord, or maybe Gonzalo just answered. But yeah, about final words, very exciting, guys, about what you are building and what you will build. And yeah, feel free to join the Discord and to ask any questions on the server. We are highly active there. I will let Ege with the final words.
Thank you, Raphael. Actually, I'll be leading the workshop we have on 5 p.m. regarding to mental models of ZKML agents. And I think it's a really important one, because a lot of people, obviously, since ZKML is such a new innovation, we don't necessarily know how to identify which cases where ZKML really brings value. Because it's not I think there's a distinction to be made there. Not every good ML case is a good ZKML case. And in my session, I'll try to bring a more methodical approach on how to identify such ZKML cases. And I'm really excited to have everyone there. I think this session is on 5 p.m. CET.
Correct. The session from 5 p.m. is going to be from Ege, and then we'll have one at 7, which is going to be led by Jakub, if I'm not mistaken. It's going to be on
tomorrow's, Satya. I believe
yes.
It's tomorrow.
Perfect. Well, thank you both. And sorry, Satya, these are going to be tomorrow, not today. Both of these sessions that we mentioned are going to be happening tomorrow. Everybody that is here should already have invites in their calendars. And also, as always, I will try and share all the links in advance through our announcement channel on Discord. We have dedicated sponsor zones, so if you have questions regarding any of the bounties or the ideas that you're working on, please make sure to post there, and we'll try and connect you to the proper teams and representatives. That is all. Thank you all for being here. Thank you, Raf and Ege, for an amazing workshop again. And yeah, looking forward to see you all tomorrow. Have a great day.
Thank you, guys.
Thank you.
See you tomorrow.